Thank you for coming to a virtual session. I know you've had a lot of choices here, so I really appreciate that. This is a little bit about me. My name is Mala. I've been part of the SQL Server community for a really long time, since 1999. I'm currently a database engineer in the town of Raleigh, North Carolina, in the US. I'm also a co-lead for two user groups, the Data Platform Women in Tech user group and the Triangle SQL Server user group. You can find me on Twitter with the hashtag SQLMAL if you have any questions after this talk. So the goals for today, we are going to understand first what is graph data, and then what are its origins and history, a really brief history, and then why is it important to learn this, then when is it appropriate to use other tools to harness its power, and the basic terminology around graph databases in general. So what we will not cover is data modeling. Data modeling around graph data is a whole talk in of itself, and a detailed tool comparison of what's available in the market. We are just not going to have time for this in 20 minutes. So let's start with why is this important to follow. There are a few reasons. The number one reason is that quite a significant amount of data and analytics innovations, they are going to be made using this technology in the upcoming years. This percentage has just been going up and up in the recent years, and it's going to be significantly high. Um, a lot of graph data is semi-structured or unstructured, and it is better represented using non-relational databases in many cases. It is well suited for big data analytics, pattern matching, and this sort of stuff. And then it has a lot of business applications, fraud detection, illness spreads, talent management, a lot of things like this. I will cover a few of them in the next slide. So this is a nice quote from the famous database expert, Joe Selko. He talks about how graph databases can answer questions that are not easy to answer in a relational database because they study relationships and not just the data in the form of entities. Um, let's start with a brief history of graph theory. This is a very common story. A lot of you may have heard of it, but I like to keep this on because it helps to understand how old this really is. This goes back to 1736, a town in Prussia called Königsberg. This is a town that was made up of two islands connected by 7 bridges, and the mayor of this town had a competition for people to walk around the entire town by crossing a bridge just once. There was a mathematician who lived then. His name was Leonhard Euler. He was able to prove that by removing one of the bridges, this traversal was possible. It is only possible by removing one of the bridges. And Euler's theory was the origin of what we call graph database and graph theory today. So it goes back to as long as 1736. Graph theory, not graph database. So it's important to remember. So let's start with what is graph data. So when we say graph, what came to my mind initially is something like this. This is what I learned in school, X and Y axis and plotting things on the graph. Now, this has nothing at all to do with graph data. Graph data, essentially, this is what we have a typical database in the relational world and how it's connected. Whereas in the graph world, the database is likely to look more like that. Now, those spider-like connections between the round circles, those are what we call interconnections. And I'll come to the terminology around it. But as you can likely see from the image itself, that there are a lot more connections in a graph database than there are in the relational world. And that's typically what characterizes the difference. So what does graph data look like? Graph data is more about relationships than it is about entities. There are a lot more relationships in graph data than there are in a typical relational database. Data that's highly interconnected, and there are many complex many-to-many relationships, many bridge tables and things like that that you would call in the relational world. So examples, there are many examples. The typical one is the social graph, or what we have on social media is one person is connected to another person, is connected to another person, and so on, forming a huge web of people. This is a very typical graph database. Buyer behavior, when you have algorithms that go after how, if you buy this, you may like that, and so on. The algorithms that traverse that kind of data, those may be graph based, a very typical example. Geospatial, the GPS that we use every day, that's based on graph data. Fraud detection, again, it goes after your buying patterns. So graph databases are extremely useful in this area when they have credit card stolen and somebody misusing it to buy things in a certain way. That's how they detect it, by looking at your buying patterns. um, Master data management, when you have a bill of materials and manufacturing stuff, when you have to break every component down into its components and its components and so on, modeling and storing those hierarchies, it's extremely good at doing that. Security model in a big data center, when you have data users and permissions, an extremely complex model in a large data center, that can count for a graph data model. And data center management also with dependencies with RCA and minimizing downtime, that can also be modeled in using a graph data. So as you can see, these are very common applications and can be extremely useful to learn. So, how do you determine if your data is a graph? The number one question you ask is, how interconnected are your entities? If there are a lot of many to many relationships, that's really important to understand. What adds the most business value? Now, this is a really, really critical question. Are you going to add business value by using more of your entities or more of your relationships? And in many cases, the answer may be both, kind of both, or somewhere in between. It's not a simple black and white answer, but it helps to examine this question if you derive value from diving deep into relationships or the nature of relationships. So an example is like this. This is a movie database that I downloaded from IMDb. A very simple relational normalized model of the movie database is going to look like this, with movies, viewers, actors, and directors, and how they are connected. There are bridge tables, as you can see, between movies and viewers, movies and actors, movies and directors, because these are many to many relationships. So if you are looking at a model like this and you have an entity-based database, the typical questions in a normal entity based world is like, how many movies belong to this genre by this director, how many viewers watch this movie maybe, and how many actors are in this movie, and that sort of a thing. But if you turn it around a little bit and look at it from a relational point of view or pattern matching type of view, you're going to ask questions that are a little bit different, like, what is the next movie this person is likely to watch? Okay, who are the other people who are like this person who watch the same movie? And so you can see a lot of recommendations come up for you on Netflix and channels like that. That's how those recommendations work, is because they go after other people who like you who watch the same movie, and what those people liked are likely to be the same thing as you like. Pattern matching. So who are the directors who have just as many viewership as this other guy? So you want to see who are some of the people like this. Maybe you're an aspiring director or somebody you know is like that, and you want to see who are the competing directors in that same area. So again, a sort of a pattern that you want to go after. And how many hops removed? This is typically the thing we use LinkedIn for quite often. It's like you want to look for a job at a certain place. You want to see how many people you know work at that place, or how many people you know who know somebody else who work at that place, how many hops removed you are. So that is typically again something that is possible using graph data. So what if your data is graph like and you have a business need to tap into, like some of the questions we saw that are relationship based, like your business needs some of them answered. So the number one thing you have to do is to look at your budget. And do you have the ability to expand into new capabilities? Because some of the tools we are going to look into, they may not be cheap. And when I say the tools, I don't necessarily mean you pay for big licensing and such. It could also mean the talent, the people who know those tools really well. So ask if you have the budget to expand into those new capabilities. Find the right combo of tools if necessary. I will talk a little bit about different tools that are available. And then do a proof of concept, critically important for anything, any software project that you're getting into a big one. Do a proof of concept before you get into recommending anything as a solution. And understand that quite a lot has been done in SQL before. SQL does not have capabilities of a graph database. It is just not that way. But There's quite a number of creative solutions that people have made to traverse graph data using SQL. So that's also important to remember. So, what are the questions to ask if your data is a graph? Like, how do you get further with it? You have to ask first if you can solve your problems with a relational database. Essentially, this boils down to how big your problem really is, or how critical it is for your business to understand, get the answers to what they're thinking. Some of the databases, like what I showed in the examples, like the social media graph and the GPS and all that, they're not the norm. They are usually part of really big businesses. Smaller businesses have smaller needs, and like I said, a lot of creative solutions have been made with SQL and such. So you have to ask yourself first if you can solve some of those problems using your relational database, maybe using a programming language or something else on top of it. Uh, if no, then can I think about my data in a different format, a graph data format? You have to do a different kind of data modeling for that. And then how do I model a graph database? These are the questions that you need to ask. We don't have time to get into graph data modeling in a lot of detail, but if you plan to go the graph database way, it is important that you need to model the graph database well. So that's a question to ask as well. So how was this done on SQL Server? Important to understand. We had a number of different ways we used to traverse graph data on SQL Server. One is the adjacency list model that's keeping the parent and child nodes on the same record. Almost everybody I know has dealt with it in the form of an org chart. You have your boss's employee ID and your ID on the same record, and you have to write different algorithms to traverse that, highly procedural algorithms, and using different types of cities and stuff. So this is an important way of doing graph algorithms in the SQL world, particularly the kind of org chart kind of models. Um, Path enumeration mode is storing the entire path as a string. That is, this is a fairly old method using hierarchy ID or closure tables. My friend Louis Davidson, he has written an excellent chapter on it in his book on data modeling. So using hierarchy IDs is one way where you store the entire path as a string. And then the nested sets model, I would not recommend this. This is really hard to work around, but you store the neighboring adjacent nodes on the same record, like you have here. Like 1 is close to 22. These are next to the same thing. So this type of doing modeling is one way of doing it. And lastly, SQL graph. SQL Graph seems to have been something that Microsoft has abandoned in the near future, but it is somewhat of a way of using graph data within relational models. So these are the ways that it was done on SQL Server and is still used in many places. So what is a graph database? Where data that's graph-like is stored, and it's normally it could be a confusing term. It's a term used for the combo of a storage engine and a query language. We in the SQL Server world, we are used to the luxury of T-SQL that comes bundled along with SQL Server. But that's not necessarily the case. Not all storage engines have their own built-in language. So there is a combo of a storage engine and a query language that you may have to pick if you go the graph database route. And this term is used in a somewhat ambiguous way because this technology itself is somewhat new. So when people say graph database, they may be referring to just the storage engine or a combo of a storage engine and a query language. So that's important to bear in mind. And there is a lot of mix and match that goes on with it. You may have a storage engine from one vendor and you may have a query language from another vendor. You have to look at compatibility issues and what goes with what here. That's really important. So types of graph databases, there are many ways you can classify them. So what I mean here is just the storage engine. So the storage engine can be either native or multi-model. This is one way to classify it. By native, it means a typical object-oriented graph-based database, and by multi-model, it's based on document or key value store base. So there are both kinds of graph databases that are around. The second way to classify it is either RDF or property graph. Property graph essentially is the very common Neo4j, that is a property graph. It's made up of entities and edges, right? Nodes are basically what are called equivalent of entities in the database world, I'm sorry. And edges are the word used for the relationships, roughly speaking. So property graphs are what use nodes and edges, and I will show an example of that. This is the most common form of graph database, and the most prominent example is Neo4j, and Tiger graph is also a property graph. RDF is the second kind of graph database. That's RDF is short for resource description framework, and it's based on a subject predicate object model. It's also called a triple store model. It's slightly different from a property graph, where you have three different nodes, sort of roughly speaking, that make up one entity. So I don't have time to get into these things in a lot of detail, but there are many. Basically, what you need to understand is that there are many kinds of graph databases, and you need to be careful and pick the right one for your needs when you decide to go this way. So graph query languages, there are multiple graph query languages also. Some of the common examples are Cypher, Gremlin, and PG-SQL. There are a number of open source languages as well. GraphQL itself is a language that's open source. And like I said before, a graph database is a mix and match between a query language and a database. So you need to pick the right combo of tools for your needs. So what are some of the basic differences between a relational database and a graph database? The basic difference is the number of connections. Like you can see here, the number of connections in a relational world is fairly simple, whereas it's mind-blowingly huge in the graph world. Um, a relational database is time-tested. It goes back to the 1980s, and we've been working with it for a seriously long time. Graph database is fairly new. It only evolved in the 2000s, and it is still an evolving technology in many ways. Pattern matching is very difficult to do in the relational world, and it's really easy in the graph database world. That's its purpose, in fact, to do good pattern matching. Visualization is not possible at all in the relational world, whereas in the graph world, it comes bundled with a lot of graph databases. It is really cool. It's really fun to work with. Query, it's object based, based on your tables. When I say object, I mean tables. I don't mean relational is object oriented, but it's based on tables. Whereas in the graph database, it's relationship based. So it's a complete shift in mindset around how you look at it. This is some of the schema. The same movie database we saw has nodes and vertices like this, and the edges are the connections between the nodes. Movies connect to genre and connect to person too. And then directed edge is what goes one way connection. Non-directed edge is one that does not have that connection. And the terminology cycles is when they are all connected in one loop, and a tree hierarchy is when it's one way. Some of the tools available, like I said, graph databases and GraphQLs that is compatible with the database, programming languages that can work with graph data or relational data, and they can give you similar results. If you have a clever programmer, they can likely work out things based on your relational database too. For simple data, work it like they've always done with T-SQL. So these are some references for anyone who's interested. Your feedback is really important to me. Please, please, please give me feedback. The link is here. And thank you. Hope you enjoy the rest of your day at SQL Bits.